So let's discuss about Planck's quantum theory of radiation. So let here N be the total number of oscillators at temperature T, E be the total energy. So if we have a N number of oscillations, so then it is for each oscillation it is considered as N0, N1, N2, N3, etc. up to of N number. For each oscillation it's having an energy, it is taken as 0, h nu, 2 h nu, 3 h nu and n h nu. So therefore for these number of oscillations for this energy at this temperature T, it is given as n is equals to n naught e to the power of minus h nu by kt, where n is called 0, 1, 2, etc. So n is equals to n naught plus n1 plus n2 plus n3 and so on. N naught, from this above expression we can consider n is equals to this n naught e to the power of minus n h nu by kt. So here substitute n is equals to 0, you will get as this n naught is written as n0 e to the power of n is 0, substituted e to the power of 0 we will get. So again substitute n1, it is substituted as n naught e to the power of minus, in place of n substitute n is equals to 1. So you'll get as n naught e to the power of minus h nu by kt. Similarly n is equals to 2, like that so on. So we have got as n. So this n is the number of oscillations for n number of oscillation at temperature T. So similarly this from this expression we can take it n naught as a common factor. N is equals to n naught common factor 1 plus e to the power of 0, it is nothing but 1 we will get, plus e to the power of minus h nu by kt plus e to the power of minus 2 h nu by kt and so on. So n is equals to n naught. This expansion it is given as, so this expansion is written as n naught 1 divided by 1 minus e to the power of minus h nu by kt by using this formula. So total energy E is given by E is equals to nh nu is our equation. So En is number of oscillation. For first oscillation, for n naught oscillation it is written as n naught into, for the first oscillation the energy n is equals to considered as a 0, therefore n naught into 0. Similarly n it is considered as a 1, therefore n1 h nu we have written plus n2 2 h nu plus so on. So that is equals to this one, this term it is written as 0 plus n naught e to the power of minus h nu by kt. Thus it is substituted as a n1 value. This is n1. This is n1 value substituted in this below equation and written h nu plus n naught, that is second term it is written as this value, that is this value, into e to the power of minus 2 h nu by kt into 2 h nu, so on. So therefore E is equals to n naught e to the power of minus h nu by kt into h nu, taken common factor from this above expression. So therefore it's remaining as this is taken outside. So therefore 1 plus 2 e to the power of minus h nu by kt plus 3 e to the power of minus 2 h nu by kt and so on. So that is equals to n naught e to the power of minus h nu by kt. So this equation again it is written as 1 divided by, in this form, in place of x it is there e to the power of minus 2 h nu, that is given as a e to the power of h nu by kt, substituted that. So 1 minus e to the power of minus h nu by kt whole square. So this is the expansion of this term. So the average energy per oscillator it is given as E bar. The average energy it is given as energy of total energy divided by the number of oscillations. Total energy it is given as E divided by number of oscillations it is given as n. So this is the total energy value, this is the number of oscillator. Divide these two values. So therefore E is n naught, this value n naught e to the power of minus h nu by kt into h nu, 1 minus e to the power of minus h nu by kt whole square, divided by n value it is written as n naught divided by 1 minus e to the power of minus h nu by kt. Cancel the term which are similar and remaining will get as average energy, that is E bar is equals to h nu divided by e to the power of h nu by kt minus 1. So now we have to find out this energy, average energy density for different frequencies, that is from nu to nu plus d nu. That is given as energy density for a different range of frequencies, that is given as E nu d nu is equals to 8 pi nu square by cq into d nu into average energy of an n number of oscillations. So that is equals to 8 pi nu square by cq. This E bar it is substituted as this equation. So therefore h nu by e to the power of h nu by kt minus 1 it is substituted into d nu. So E nu d nu is equals to 8 pi h nu cube divided by c cube 1 divided by e to the power of h nu by kt minus 1 into d nu. So this equation it is called as a Planck's formula in terms of what? Frequency. So that Planck's formula written in terms of wavelength, that is given as nu is equals to c by lambda. It is the relation between the wavelength and frequency. It is given as a nu is equals to c by lambda. Differentiate this in terms of d nu. So therefore we will get as a d nu is equals to minus c by lambda square into d lambda. So therefore this in place of nu we are substituting lambda. So therefore E lambda into d lambda is equals to 8 pi h. In place of nu square I have substituted c by lambda, that is c by lambda to the power of 5 1 divided by e to the power of h nu by lambda kt minus 1 into d nu. So from this Planck's formula in terms of wavelength we got. So using these two equations, let's derive Wien's displacement law and as well as a Rayleigh-Jeans law. So Wien's displacement law is applicable only for shorter wavelength, that is given as e to the power of h nu divided by hc by lambda kt is should be very much greater than 1. So that is written for a longer frequency, shorter wavelength. So therefore shorter wavelength it is written as this is should be as a greater than, very much greater than 1. So E nu d nu is equals to 8 pi hc by lambda to the power of 5, and this equation directly it is substituted as e to the power of minus hc by lambda kt into d lambda. So this we called as a Wien's displacement law. So now we'll discuss about the Rayleigh-Jeans law. For longer wavelength, so if the wavelength is longer, then it is taken as this term again, e to the power of hc by lambda kt, that is equal to 1 plus hc by lambda kt. Here it is what happens, it is greater than 1. But this value here in the longer wavelength, it becomes as a 1 plus hc by lambda kt. E lambda into d lambda is equals to 8 pi hc by lambda to the power of 5 1 divided by, substitute this value in this equation. So we will get as 1 plus hc by lambda kt minus 1 into d lambda. So the cancel the term which are similar. Finally we will get as equation E lambda d lambda is equals to 8 pi kt divided by lambda to the power of 4 into d lambda. So this is about the Planck's quantum theory of radiation. Thank you.